I wanted to go back over how I'm filling in the proof, just so everyone's on the same page in case you get confused this weekend if you're looking back over your notes, because we have a test next Wednesday. So back to, I can forgive you for a lot of things, but you've got to get the given, and you've got to get the proof in the right spot every single time. You cannot mess that up. Then my next step is I see they wrote definition of congruent segments, and that means we get to drop the squiggle in the bars. So I know AB equals CD. Now I know that one because they wrote definition of congruent segments here. But I also know that's what they're looking for because when I look at 3 and 5 and 6 and 7, for instance, I notice that the bar is removed from on top of AB, and I notice the squiggle's not above the equal to sign anymore. So that's another sign showing me what I need to do. And I still haven't even read the problem to make sure I know what I'm doing. So let me read back through the problem. It says, prove that if AB is congruent to CD, then AC, all the way from here, all the way to here, is congruent to BD. Well, the section that I colored 2 different colors, let me zoom in and see if I can show you again. They said AB is congruent to CD. And then they said, knowing that, can we show AC is congruent to BD? And it's hard to see because of the overlap, but I colored the segment BC both orange and yellow because we're using it with both pieces. We're using it with both AC and with BD. Okay, so no surprise on line 3. They say BC equals BC. They're saying we're using BC for the yellow and we're using BC for the orange. So that's why they bothered to show that in there. And we know that is the reflexive property. I think everyone in the room would guess that one right. Now I get to line 4 and it says segment addition postulate. So I've got to do something with the segment addition postulate over here. So the segment addition postulate, just as a reminder, it says if we do the tiny piece plus the tiny piece equals the whole thing. So what's interesting about this problem is there are 2 different segment addition postulates I could write. I could write one for AC, so AB plus BC equals AC. Or I could write one for BD, and that would be BC plus CD equals BD. So technically I can write it twice. There are 2 different segments that could use the segment addition postulate. And I know there's a problem on the worksheet that even has 3 segments that use segment addition postulate. So it's okay to use the segment addition postulate multiple times. Now, in this first blank, in blank 4, we're going to use the pink piece. So AB plus BC equals AC. And you'll say, Ms. Compton, why did you know to do the pink segment addition postulate and not the purple one? Back to I'm using my context clues. I saw on line 5 they had something about AC, so I knew to use the one that had the letters AC, which is the pink, not the purple. So I used my segment addition postulate. Now they filled in line 5, but if I pay careful attention, I notice 4 and 5 are very, very similar. 4 says AB, BC, AC. 5 says CD, BC, AC. They have everything in common except these 2 pieces. They're replacing AB with CD. And they can do that because back in step 2 we realized they were equal. So anytime we're replacing someone with someone else, we're doing substitution. So they were equal. It's like they were both quarterbacks. So since we're pulling out that quarterback, we've got to put in another quarterback. And anytime that happens in the game or in a proof, we call that substitution. Now line 6 says CD plus BC equals BD. And I get why some people are frustrated by that line, except I've written at the top this purple one, and we haven't used it yet. And I noticed that even though my letters aren't in the exact same order, they're very similar. Because So I had CD, there's a CD. I had BC up here, there's a BC down here. I had BD, there's a BD. Oh my goodness, I've already written it at the top of my paper. And if you recall, I wrote the pink segment addition postulate and I wrote a purple segment addition postulate. So I guess now I'm finally using that purple segment addition postulate. Now, if we're really trying to be smart and just so snazzy, notice that anytime we start doing the plus sign, so like AB plus BC equals AC, or CD plus BC equals BD, anytime you start seeing the plus sign in a proof, you can just go ahead and guess it's the segment addition postulate. Because the segment addition postulate is with addition, so naturally it has a plus sign. That makes so much sense. Okay, last but not least, all of a sudden, they went from not having a squiggle to having a squiggle. Now, how did that happen? Well, anytime we're talking about adding on or removing squiggles, it's the definition of congruence. Now, I don't bother to write out congruent segments. I just put the congruent symbol because I don't have all day because proof's already taken me long enough. So if you understood how we fill in each piece, I guess we should look back over the whole overall thing to see what was the point. What was the point? So step 1, they gave us the 2 dash pieces. Step 2, they're saying the 2 dash pieces match in length. So if AB is 4, BC is also 4. Step 3, AB is 4, then CD is also 4. Goodness. Step 3 is notice the overlap. So we compared the fact that this pink piece has a 2 dash, this purple piece has a 2 dash, and now we're even noticing that they have an overlap with BC. They share that segment. Step 4 is talking about how the pink piece is made up of AB plus BC. That makes up the entire pink piece. That is the segment addition postulate. Step 5 is referring back to step 2. We already found out that this 2 dash piece goes with that 2 dash piece, so why can we not replace it in our proof? Step 6 is still in that segment addition postulate, that BC plus CD equals BD, back to talking about the whole length of that purple segment. And then step 7 says AC equals BD. Well, we know AC equals BD because back to we showed the 2 dashes match, we showed the overlap, now we can assume the pink equals the purple. We've got it done. The proofs are overly complicated in that, like with the algebra one, we're doing so many steps to show something we automatically recognize from the picture. Just like in my example about making a peanut butter sandwich. We can go super detailed if we want. We can go really generic if we want. I didn't work example 2 in any classroom except first, and I kind of butchered it in first, so I want to go over it again now. Now, thankfully, your proofs have more pieces given to you. My first step is to write the given, and while Ms. Compton normally writes all the pieces of the given in one step, I know this one I got from the book. I know they broke the given up into 2 pieces. They put part of the given there, and they put part of the given on line 3. So we wrote down this part of the given. Now I'm going to write down the rest of the given on line 3. So YZ congruent to XZ, XZ congruent to WX. That's their choice. Now line 2 says definition of congruent segment. So to go from line 1 to line 2, I realized, hey, I probably need to add the bar so we know it's a line segment and add the congruent symbol. And now Ms. Compton has not even done the easiest part. I already know what goes on line 5. So all I'm lacking is line 4. I've got to figure out what to put on line 4. And I still haven't examined the picture or really thought through the problem. I've just been kind of guessing or just fumbling my way through the proof. So back to the given, it says prove if given wy is equal to yz. And we know that, look, they both have 3 on them. So they're both length 3. We know that yz is congruent to xz, hence why they have the 1 dashes. We know that xz is congruent to xw, hence why they have 1 dashes. And they want us to show that wx is equal to wy. Well, we know we can add the dash to wy because it and yz are the same length. So that's really what we're covering in 1 and 2, is the fact that that one has a 3 and that one has a 3, and therefore we can add a dash to wy. That's what 1 and 2 is handling. Number 3 is making you notice all the other dashes, the fact that everybody else already has a dash mark. And then step 4, it's my favorite property. I noticed on the given that the same letters kept happening. So we had yz is equal to xz. We had wx is equal to xz. So then why on earth can't we skip the middleman and go straight to wx is equal to yz? Actually congruent to yz. And since I'm skipping the middleman, you know that is the transitive property. On the next line, notice that yz has suddenly changed into wy, and that's allowed because look at what you wrote on step 2. They are equal. So it's like we pulled out a quarterback and we replaced it with another quarterback, so are we surprised if they call that substitution? No, not really. Now, for those who are really trying to be overachievers, it is possible to add more steps to this proof. I went ahead and inverted it between line 3 and 4 to be wx on the left-hand side the way I want it. But if we wanted to add like a step 3a here, we could. Yz was on the left-hand side in my given. Wx was on the right-hand side in my given. So technically for me to flip-flop it and put wx on the left and yz on the right, technically I've done the symmetric property. But is that 100% necessary? No. I think you followed me until there. As long as you can get the given in the end and try to make a logical argument in between, I can try to be as nice as possible. Let me know if you have any questions, and I will be here 0 period Monday morning.